All right, so the 10 kilogram box, Newton's second law says negative 100, 0, plus 0, negative 98.1, plus 0, n1, plus 0.1, n1, 0, plus t 0 is equal to 10 times a 0. This is for the 10 kilogram. And then for the 15 kilogram, we have negative 0.1 n1, 0, plus 0 n1, 0 negative n1, because it's pointing down here, plus t0, plus 0 n2, plus negative 0.2 n2, 0, plus 0 negative 147.15 is equal to 15 times negative a0. And which one I called positive a and which one I called negative a was just arbitrary. If this ended up being negative, this would end up being positive. The key thing is that those just have opposite signs. N1 is equal to 98.1. That comes from equation 2 here. And so N2 is equal to 147 plus 98. What's that? N2 is equal to 245.25. And so now we have two equations for two unknowns. Negative 100 plus 0.1 times 98.1 plus t is equal to 10a. And then the x equation for the 15 kilogram box says negative 0.1 times 98.1 plus t minus 0.2 times 245.25 is equal to negative 15a. So the first equation says, does anyone, yep. This, so remember in the 15 kilogram box that N1 is acting down. Okay, that's an equal and opposite thing. This is a Newton's third law thing. This whole combination of forces is like if you added it all up, is the force on the 10 by the 15. Okay, and so that means that it has to be in the opposite direction over here, because this is the force on the 15 by the 10. And that's why these are both in the opposite direction of these. Okay, so the first equation here says negative 100 plus 9.81. That's 91 point. What? 19 plus t is equal to 10a. And the second equation says, what do these constants add up to? Negative 58.86 plus t is equal to negative 15a. So one way you could solve this, you could do it by substitution. You can also just, so if this is true, you can multiply both sides. Like this equation, you can multiply both sides by -1 and get this. And now add those two together. Add these two equations together and you get 149, I guess, 0.05. Is equal to 25a. And so what do you get for a? A is 5.96 meters per second squared. Okay, so the acceleration vector of the 10 kilogram box is 5.96 meters per second squared, 0. And the acceleration of the 15 kilogram box is negative 5.96 meters per second squared, 0. Anybody get all the way through that? Anybody get through the free body diagrams? Okay. So that's really like the key to it. The rest of it is just sort of algebra and stuff, but that kind of problem is about as hard as this sort of stuff can get. Yeah. Anybody have any questions about any of the songs we heard here today? They're mostly sort of slow jams from the early 80s, featuring Lionel Richie, Simply Red, George Benson. Actually, I thought of that song because I just heard, like, he just had a concert recently and sang that song that I saw on public TV or something. It depends. It just depends what I did it so that the top box, a positive value meant a vector of this was my acceleration vector. So you take that variable and just plug it back into the vector. And so no, it was accelerating to the right, which just means that the friction was slowing it down.